We're going to look at trig values in all quadrants. If we go back to our angle pi over 6, which, if you remember, is a 30-degree angle, I drop an altitude to the positive x-axis to create a right triangle. Radius is 1. This is now a 30, 60, 90 triangle with a hypotenuse of 1. So the short leg is 1/2, and the long leg is √3/2. So the ordered pair to get to this point would be √3/2, 1/2. We could do the same approach in each of the other quadrants. Triangle with a pi over 6 angle near the origin, drop an altitude always to the x-axis. Then I created another right triangle with a 30-degree angle here, 60 here, right angle here. The radius is 1. So just like the first triangle, the short leg is 1/2 and the long leg is √3/2. So these are the same, I just did a reflection in the y-axis. The ordered pair, though, is not √3/2, 1/2. It would be negative √3/2, positive 1/2, to get to this point on the unit circle. So everything looks the same, except we're going in the other direction as far as the x-coordinate goes. Now I'm going to do the same thing in the third quadrant. So in the third quadrant, if I have an angle based on pi over 6, that's a 30-degree angle. There's your right angle. The short leg is 1/2. The hypotenuse is 1. The long leg is √3/2. What's the ordered pair down here? Negative √3/2, negative 1/2. Okay, we could do that again in the fourth quadrant. So in the fourth quadrant, what would the ordered pair be down here? Positive √3/2 and negative 1/2. Now, I based all 4 triangles off of an angle of 30 degrees, or pi over 6. But what angles are they actually? This first one in quadrant 1 is pi over 6. When we go around to the terminal side of this angle, we are in the second quadrant. So the angle we're actually talking about is 5 pi over 6. When you get to pi, that's 6 pi over 6, and then the angle going around into the third quadrant is 7 pi over 6. And the angle going all the way around into the fourth quadrant is 11 pi over 6. So now we can look at trig values. Now that all the ordered pairs are here, I can ask you, what's the sine of 5 pi over 6? Well, the sine of 5 pi over 6 corresponds to the y-coordinate of this point. So the x-coordinate is the cosine of our angle, which is 5 pi over 6. The y-coordinate is the sine of 5 pi over 6. So the sine of 5 pi over 6 is positive 1/2. Notice how the cosine of 5 pi over 6 is negative √3/2. So you have to be mindful of the quadrants you're in. In the first quadrant, it's nice. The ordered pairs are positive values. In the second quadrant, then it's negative positive. The third quadrant, your values are negative for the coordinates. And then in the fourth quadrant, it's positive, negative. So every time you do this, you'll have to think about what quadrant you're in for which coordinate. Notice in the third quadrant, the cosine of 7 pi over 6 is negative √3/2. The sine of 7 pi over 6 is negative 1/2. In the fourth quadrant, the cosine of 11 pi over 6 is positive √3/2, and the sine of 11 pi over 6 is negative 1/2. For an angle of pi over 4, that's like a 45-degree angle. I'll drop an altitude down, creating a 45, 90 with a hypotenuse of 1. So the legs are √2/2. Do you remember the ordered pair for this point on the circle? It would be positive √2/2, positive √2/2. So the cosine of pi over 4 is √2/2, and the sine of pi over 4 is √2/2. Now when I go into quadrant 2, and I base my triangle, here's the triangle, I base it off of a pi over 4 down here by the origin, this will actually be the angle 3 pi over 4. What would the ordered pair be here? To get to that point on the circle, I would have to go to the left the same distance as I did over there. So I'd have to go left root 2 over 2, so that's negative root 2 over 2. And then I'll go up, so positive root 2 over 2. And then in the third quadrant, the ordered pair at this point will be negative root 2 over 2, negative root 2 over 2. So the sine and the cosine will have the same values. This angle was 5 pi over 4, and in the fourth quadrant, going all the way around, is going to be 7 pi over 4. And the ordered pair for this point would be positive root 2 over 2, negative root 2 over 2. So if I ask you, what's the sine of 7 pi over 4? You might have to think about this is based off of pi over 4, and pi over 4 angles have a sine and cosine of root 2 over 2. So I know I'm going to have a root 2 over 2, but then I have to think, what quadrant is 7 pi over 4 in? 7 pi over 4 is in the fourth quadrant, where the coordinates go positive then negative. And sine is the second coordinate. So it's going to be negative root 2 over 2 for the sine of 7 pi over 4. Okay, when I have the angle pi over 3, which is a 60-degree angle, I will create a 30, 60, 90. You know that across from the 60-degree angle is the long leg, that's the root 3 over 2 leg, and the short leg is 1/2. So the ordered pair in the first quadrant will be positive 1/2 root 3 over 2. So that's the pi over 3 angle. In the second quadrant, when we rotate around, we actually go to the 2 pi over 3 angle. The ordered pair in that situation is going to be negative 1/2 to get to this point, and then positive root 3 over 2. So the cosine of 2 pi over 3 is negative 1/2, because we're in the second quadrant where the x-coordinate is negative. The sine of 2 pi over 3 is positive root 3 over 2. In the third quadrant, the angle going all the way into the third quadrant with a denominator of 3 is 4 pi over 3. The ordered pair there is negative 1/2, negative root 3 over 2. The angle going all the way around to the fourth quadrant is the angle 5 pi over 3, and the ordered pair there is positive 1/2, negative root 3 over 2. So if we ask you to do some trig values with denominators of 3, like the sine of 2 pi over 3. The sine of 2 pi over 3, now that's in the second quadrant. When you have a denominator of 3, the y-coordinate is larger than the x-coordinate. So it's going to be a root 3 over 2. And in the second quadrant, sine is positive. What about tangent? What would the tangent of 5 pi over 3 be? Do you remember that tangent is sine over cosine? You could look at it that way, or if we're working on 5 pi over 3 and you have to find tangent, you could use opposite over adjacent. So that's another option, which is exactly what I'm doing here. The sine of 5 pi over 3 is this y-coordinate, so it's negative root 3 over 2. The cosine of 5 pi over 3 is positive 1/2. And we know the 2's are going to cancel, so the answer is negative root 3. We should also look at the angles that we get at the top and bottom and right and left. So we call these quadrant angles. When we're over here, we could be talking about 0 radians, or we could be talking about 2 pi radians. The ordered pair over here is 1, 0. Remember, the x-coordinate is your cosine, I'll use 0, and the y-coordinate is your sine. So the cosine of 0 is 1 and the sine of 0 is 0. You could also tell me that the cosine of 2 pi is 1 and the sine of 2 pi is 0. But let's move around some more. We've already visited pi over 2. Let's review. The ordered pair here is 0, 1. So the sine of pi over 2 is 1. The cosine of pi over 2 is 0. Now look at this ordered pair. What's the ordered pair at this point? -1, 0 is the ordered pair. So the sine of pi is 0, and the cosine of pi is -1. What's the tangent of pi? Tangent is sine divided by cosine. So I'm going to put 0 over -1. What does that give me? Gives me 0. Okay, one more. This point has an ordered pair of 0, -1. So the sine of 3 pi over 2 is -1. The cosine of 3 pi over 2, the tangent of 3 pi over 2 is sine over cosine. We know sine is -1 and cosine is 0. This results in an undefined answer.